So, lecture 3.4. So we're going to be looking at the real zeros of polynomials. Okay? And real quick, when we're talking about the zero of something, that's talking about the roots or the answer to our equation, or where we're crossing the x-axis. Okay? So those are the roots. If I have a graph, these are the roots that we are looking for. All right, so here's a real quick question though. What do we need to know in order to graph the function p of x equals in this polynomial form? Take a second and think, what do we need to know in order to graph one of these polynomials? Okay, well, one thing that we went over before is we want to know the end behavior. Okay, what does the end behavior of the graph look like? Do we have them both pointing up, one down? Remember, there were 4 different options that we had. So that's one thing, end behavior. Second thing we want to look at are the x-intercepts, or our zeros. Third thing would be the y-intercepts. And then fourth would be any extra points if needed. If we're not sure if our graph maybe was above or below the axis, as we did before when we were checking some test points. All right, so let's take a look at the rational zero theorem. So the possible rational zeros, okay, so this is talking about rational numbers, so the numbers like 2, a half, a third, nothing like the square root of pi or anything. So rational numbers. So the rational zeros of the polynomial, generic form of a polynomial, and we know the possible zeros. Okay, so notice it says possible. We're not for sure these are the actual zeros. The possible zeros are in the form of c divided by L, where c is a factor of a sub 0. So c comes from the end value, the constant. And L is a factor of an, the leading coefficient. Okay, let me just real quick grab my color code in here. All right, so if we take the leading coefficient and we take the constant and we divide the constant, okay, this is where it's kind of odd, you're dividing the constant by the leading coefficient. If you do that and you take all the possible factors of this, then one of those numbers will be a 0. Or you could say it would be an x-intercept. Okay, so let's take a look at these. So we're given the function p of x equals, and here's our long polynomial. So the first thing we want to do is list all of the possible rational zeros. Okay, so let's see. Well, I know my rational zeros are going to be c divided by L. So the question is, what are the factors of c? Well, first off, c is my 4. Okay, so notice I'm just going to take 4 because I'll tell you why in a second. And then L is, oh gosh, what is L? Well, L is going to be, remember, we have that invisible one that hangs out in front of the x. Okay, so C is going to be factors of 4, and L is going to be factors of 1. All right, so when we do this, the factors of 4 are going to be, and we take the positive or negative of all these options. So that's why I didn't take the negative 4 when I wrote down factors of 4, because we're gonna look at the positive and negatives of the factors anyway. So we don't need to take the negative. So I want to look at the positive and negative factors of, well, what are the factors of 4? Let's see, 4 is divisible by 1, 2, and 4. Okay, 1, 2, and 4. Those are the factors of 4. And we're going to divide those by factors of 1. Well, that's easy. Factors of 1 are just 1. All right, so what are the possibilities? Well, actually, this one's really easy because factors of 1, we only have 1. If this number had been 6, we would end up with a lot more options. And we'll see an example of that shortly. But for now, what I'd like to do is I just take the bottom number and I just individually check what that fraction would be. So 1 divided by 1 would be 1. And then 2 divided by 1 would just be 2. And 4 divided by 1 would be 4. So these are the possible rational zeros of p of x. Okay, and when you're writing your workout, you don't need to write out the whole thing, possible rational zeros of x. You can just write out possible. You could actually just write out possible. Ooh, gosh, here we go. Possible zeros. Okay, you could write that out. Just label them for me when I look at your work. All right. Okay, so that was part A. We have 6 possible rational zeros. Okay, and I said 6 because we have the positive and negatives of all of them. So part B. We want to factor p of x completely over the real numbers. All right, so, well, we've already gone over how to do synthetic division, synthetic long division, so we're going to go ahead and use that for factoring. All right, so here we go. I'm going to pick one of these. Now remember, there are 6. I normally just go with positive 1 first because that's sort of rather a simpler one. So I'll start with dividing my polynomial by 1 and see if this is a 0. Okay, so let's go. There's my polynomial values. Remember the negatives, let's not drop any. All right, so bringing down the 1. 1 times 1 is just going to be 1. Adding 4 plus 1 is 5. 1 times 5 is going to be 5. Adding that, 8. 1 times 8, 8. Adding those, that's going to be 4. 1 times 4 is going to be 4. And adding those final two, negative 4 plus 4, will give me that 0 that I want. Alrighty. So I have found out that 1 is indeed a factor of my polynomial. Okay. And that was one of my possible rational zeros. All right, awesome. That was nice. That happened in the first round. Okay, so let's see. So we have x minus 1 times, what's left over? X to the third power plus 5x squared, and then plus the 8x, lastly plus 4. All right, so now what I'm going to do, because I managed to factor this, you could go back and try check these rationals with the original polynomial, but now I just want to factor this one. Okay, so let's see, possible rationals for these. Possible zeros for this one are going to be, well, I take the c value, 4, and the l value, 1, and I'll check those out. Those are going to give me actually the same options as before, plus or minus 1, 2, and 4. Okay, so same thing we did for part A, we're doing for this one. So now I'm going to go ahead and pick one of these and see if it's a possible 0 for this polynomial. I'll go ahead and pick a positive 1 again and see how that works. So let's say we have 1, 5, 8, and 4. All right, let's go ahead, synthetic long division. Bring down the 1. 1 times 1, 1. Add, 6. 1 times 6, 6. Add, what's that, 14? 1 times 14, 14. Add, oh darn, that's a 28. Okay, that's not a possible 0. All right, let's pick a different one. How about, let's do negative 1. Okay, same thing. Let's do the long division. Bring down that 1. 1. Sorry, synthetic division. Multiplying that out, that's going to be negative 1. 5 plus negative 1. 4. Negative 1 times 4. Negative 4. Add that. 4. Negative 1 times 4. Negative 4. Add that. Aha! 0. We found another factor. So, we'll bring down my original factor here, x minus 1. And then I found out that this factors into my new value here, x plus the 1. And then what's left over? X to the second power plus 4x plus 4. Okay, so I'm going to see if I can factor this. Well, we could go ahead and then find the possible rational zeros, go through the synthetic long division, but ask yourself, do we know how to factor this? We do. That one right there is going to be, let's write this down, this trinomial factors into x plus 2 times x plus 2. So, right there, I have my factored form. All right, so p of x is x minus 1 times x plus 1, and then I'll just group x plus 2 as squared. All right, so we have managed to factor it. So what we did was, in the beginning, we just found possible rational zeros, found one that equaled 0, so we were able to factor. We had to go through the cycle again to factor this new polynomial we created. We tried once and it didn't work. We tried again and we found a 0, so we knew that was a factor. Because the denominator was, because the remainder was 0, we knew it was a factor. So then we had our new factored form, and then we were finally able to factor this last piece, so we ended up with an entirely factored polynomial. Now, when we have our entirely factored polynomial, I can easily pick off my real zeros, which is part C. So the real zeros, and when you write this out, please do write out real zeros of p of x, are going to be, we take these values. So x equals 1 came from there, x equals negative 1 came from that one, and then x equals negative 2 came from that. Okay, so notice we only had 3 real zeros, but the possible zeros, we had 6 possible zeros. Okay, so notice not all of the possible rational zeros actually do or actually are zeros for your polynomial. Okay, they're just the possible ones. So in the end, we want to figure out which ones are really actually the zeros for my polynomial. All right, example 2. All right, so same thing's going to happen here, but this time it bumped up a little. All right, so part A. Go ahead and try pause the video and see if you can list all the possible rational zeros. Okay, so let's see. C is going to be factors of, oop, there went my pen. All right, factors of 4. And L is going to be factors of 3, which I get from there. All right, so what are those possibilities? Well, factors of 4 are 1, 2, and 4. And factors of 3 are 1 and 3. This changes things up a little bit. So when we do our possible zeros, okay, remember we take the positive or negative versions of all of them. And what I'm going to do here first is I'm going to focus on making everything over 1. And then I'll focus on the 3. So for now we have 1 over 1, which will be 1. And then 2 over 1, which is 2. And 4 over 1, which is 4. Okay, so now we're done with looking at the 1. Let's look at the 3. We have the option of 1 over 3. Well, we don't have that now, so we're going to add that one in. 1 over 3 is a possible 0. And then 2 over 3. And lastly, 4 over 3 is a possible 0. All right, so here we go. We have our possible zeros, and in reality, there are 12 because we take the positive options and the negative options. That is a lot of possible zeros to test. All right, but let's go ahead. I always start with 1, so why not? Let's check out 1 to see if this is a possible 0. Oh, sorry, excuse me, I just skipped this. Part B, factor completely. Okay, so our goal is to factor, so I'm going to find a 0. All right, so plugging in 1. Let's see, my polynomial is 3, negative 5, negative 8, 10, and 4. Let's see if this baby is a 0. All right, bring it down, 3. 1 times 3 is 3. That's going to be negative 2. 1 times negative 2 would be negative 2. That's going to be negative 10. 1 times negative 10 is negative 10. That's going to be 0. 1 times 0 is 0. And 4 plus 0 is, that's 4. Okay, this is not a possible 0. Shucks. Let's try another one. How about 2? Okay, so once again, plugging in the values for my polynomial for this synthetic long division. Bring down that 3 to start the cycle. 2 times 3 is 6. Negative 5 plus 6 is 1. 2 times 1, 2. Negative 6. Go ahead and see if you can finish the rest and see if this is a possible 0 or not. Okay, it's still going. That's negative 12, negative 2, 2 times negative 2. Aha! 4 minus 4 will be 0. There we go. I have found a 0. So we have that x minus 2 times, here's our new values for a polynomial, 3x to the third power plus x squared minus 6x minus 2. There we go. We have managed to factor it a teeny bit. We're almost there, but we have managed to factor our polynomial. All right, same thing's going to happen. This time I'm going to look at the new, smaller polynomial, find the possible zeros, and then see if I can actually pull out a 0. So my c value is 2. Remember, we don't take the positive or negatives on that. And my L value is 3. Which means, looking at the factors of 2 is just 1 and 2, and the factors of 3 are 1 and 3. So my possible zeros are going to be, I'll do the ones first, plus or minus 1, and then 2 over 1 is 2. And then let's look at the 3. 1 over 3, and then 2 over 3. Okay, so we have 8 possible zeros. For fun, let's try one of the weird ones. How about negative 1/3? Let's try this one, see if that's one of our roots. Okay, so our new polynomial, 3, 1, negative 6, negative 2. Okay, let's start the cycle. Bring down the 3. A third times 3, so a negative third times 3 is going to be negative 1. Add that, that's going to be 0. A negative third times 0 is going to be 0. Bring that down, it's going to be negative 6 plus 0, which is negative 6. Multiplying, a negative third times a negative 6 is going to be a positive 2. And what do you know? Negative 2 plus 2 is 0. That right there is a possible 0, or that is 0, actually. Okay, so yes, I had done this problem before, and I knew that negative 1/3 was going to be a 0. I cheated a little bit. All right, so that means that this polynomial my screen just changed.